In the previous video, we've had a look at how we can fill up the electrons of various atoms, and so yeah, we had studied about the rule of 2n square, which gives us the maximum capacity of any given shell. But the problem with that rule is that it has some limitations. So that rule can be applied only to a certain number of elements, namely the first 18 elements. And so just to remove complications and keep things simple at this level, we'll be having a look at only the first 18 elements that we have, and not the remaining 100 elements. So we'll focus on them, and in higher classes you'll be looking at the other elements, and you'll understand how actually electrons are filled, because this thing is a bit more complicated than we actually are learning at this level. There are other things to keep in mind. So yeah, in this video I'll be telling you something else about electrons, which is stability. So stability is a sort of stability simply tells us how stable any given atom is. That is very clear from its name itself. So let's say, for example, I have two elements. Let me just randomly take something like, let me take nitrogen. So nitrogen has 7 protons in its nucleus and 7 neutrons, and thus for it to be neutral, it should have 7 electrons, right? So how would we fill up the electrons, the 7 electrons? We would fill up 2 electrons. Let me just draw the nucleus, 7 protons, 7 neutrons. So I'll put in 2 electrons here and then move to the next, because that's how many electrons can be fitted in that shell. 2, 3, 4, 5, 6, 7. Nitrogen has only 7 outermost 7 electrons, and so I fill them in this way: 1, 2, 3, 4, 5, 6, 7. Yeah, there I go, and I have filled up all the electrons. Now what scientists observed in those earlier days was that if you have atoms like, let's say I have helium, which has its nucleus in the center and 2 electrons, or let's say I have some other element like neon, which has let me just check. Neon has 10 electrons in total. So if I draw neon, it will have 2 electrons there and the remaining 8 electrons. So it has 10 electrons in total: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons in total. 2 in this shell, 8 in the outermost, in the second shell, and that's it, right? Now if I let me observe these 2 atoms here. What I can see common in these 2 atoms is that their outermost shell is completely filled up. Here I can accommodate in the outermost shell, which is this shell, I can fill up to 2 electrons, and I have filled up to 2 electrons. I have filled 2 electrons in this case. Here in this case I can fill up in the second shell, which is the outermost shell, I can fill up to 8 electrons, and that is very clear. I have filled up 8 electrons: 1, 2, 3, 4, 5, 6, 7, 8. Right? So what they observed is that such atoms that have a completely filled outermost shell, they are much more stable than atoms like this, which have only 1, 2, 3, 4, 5 in the outermost shell, whereas you can fit up to 8 electrons. So you haven't filled the outermost shell completely in such atoms, and such atoms that have a completely filled outermost shell are much more stable than such atoms that do not have a completely filled outermost shell. Also, what they observed, except for this one atom here, helium, is that they observed that the outermost shell has 8 electrons. Now I'm only talking about I'll only be sticking up to the first 18 elements, because obviously the octet rule can still be applied to other elements after the atomic number 18, but then you will be confused as to which rule to apply, 2n square or the octet rule. So octet rule is generally more prominent than the rule 2n square, because the rule 2n square does not stops applying after the atomic number 18, but the octet rule continues to be applied. But yeah, the basic idea here is, so if we stick to the first 18 elements, is that the outermost shell has generally 8 electrons in such cases where you have maximum stability. And so what electrons want to have is that they want 8 electrons in their outermost shell. Now I'm telling you, I'm using the word want here, but obviously electrons cannot want to do something, or atoms cannot want to do something, because they are non-living, they don't have life. But yeah, the basic idea is that they become more stable when they have 8 electrons in their outermost shell, because that makes their outermost shell completely filled up. Now an exception to this is helium, because helium is stable when it has only 2 electrons in its outermost shell, because its outermost shell can accommodate only that many electrons. But apart from that, if we come to neon, even neon has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outermost shell. So it follows the octet rule, it is very stable, and it also follows the 2n square rule. Now if I also go on to argon, argon is the element with the atomic number 18. Let us look at its electronic configuration. So this is its nucleus with 18 protons and around the same number of, so it has 22 neutrons, and then I have the first shell 2 electrons, the next shell 1, 2, and I can put in 8 electrons here, 1, 2, 3, 4, 5, 6, 7, 8. Now I have filled this up completely. Now I move to the next one. So I filled up 10 electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I can fill up the remaining 8 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7, 8, right? So even here in argon I can observe that I have 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outermost shell. So, and argon, neon and helium are one of the most stable elements on Earth, and it is clear that these two follow the octet rule because they have 8 electrons in the outermost shell and they are very stable. Yeah, and so we'll be sticking to only these many elements. I won't go beyond this, and just to keep it simple. But the basic idea is the 2n square rule can be applied up to the atomic number 18. But yeah, it is the octet rule that you need to keep in mind. So I'll just write the name here, octet, which simply means 8, octet rule, which simply states that any element would want to have 8 electrons in its outermost shell, and that would make it much more stable. So as in the case of, let's say, nitrogen, which has only 5 electrons in its outermost shell, it would want to somehow get 3 electrons from somewhere to make its outermost shell have 8 electrons, and that would make it much more stable. And that is the octet rule, which just simply states that every atom loves 8 electrons in its outermost shell. So yeah, that is it for this video, and I hope you understood the octet rule. So keep this octet rule in mind and keep that 2n square rule in the back of your mind, because this thing is more important. That's it for this video.